Hey everyone, welcome back. Today we're talking about operations on radical expressions. Now the first operations we're going to talk about are addition and subtraction. And in order to add or subtract radicals, they need to be like radicals. And like radicals have the same radicand and the same index. Remember that the radicand is the number under the square root. So it's the x here. And the index is this little number on the outside, that n. The first four examples we have say, if possible, simplify the expression and assume that all variables are positive. In example 1, we have the square root of 3 plus the cube root of 3. Well, these don't have the same index, so we can't add them, right? The first one is a square root, which has an index of 2. And the second one is a cube root with an index of 3. So for this, we're just going to say that it's not possible. Now in example 2, we're taking the cube root of 16 and adding it to 3 times the cube root of 2. Here we have the same index, 3, for both of our terms, but right now the radicands aren't the same. The first radicand is 16 and the second's a 2. But we can simplify this first one. Notice that the cube root of 16 is the same as the cube root of 8 times 2. And we can rewrite our second term. And we can take the cube root of 8. The cube root of 8 is 2. So this simplifies to 2 times the cube root of 2. Plus 3 times the cube root of 2. Now, because they have the same radicand, 2, and still the same index, 3, we can add these. We have 2 of the cube root of 2 plus 3 of the cube root of 2. And 2 plus 3 is 5, so we have 5 of the cube root of 2. Let's look at example 3. Here we have 3 terms, and notice that all 3 terms have the same index, but they don't have the same radicand. So we want to look at each term and see if we can simplify them anymore. Well, the first term, the square root of 2k, we can't take the square root of 2 or k, so that's as simplified as it can get. The second one is the square root of 8k. Well, 8 is the same as 4 times 2. And we can take the square root of 4, right? The square root of 4 is 2. So this simplifies to 2 square root of 2k. And we can bring our first term down. And now look at that last term. 18k is the radicand. Well, 18 is 9 times 2. And the square root of 9 is 3, which leaves a radicand of 2k. So now all 3 terms have the same radicand, 2k. So we can add the coefficients in front of them. 3 plus 2 plus 3 is 8. So we have 8 square root of 2k. What about example 4? We have 3 terms again. Notice that the first 2 terms have the same index of 3. They're both cube roots. But that third term is a square root. So we're not going to be able to subtract that square root. But we can combine the first 2 terms. So let's begin by simplifying them to see if we can get them to have the same radicand. So the first term, the cube root of 16. Well, 16 is the same as 8 times 2. And remember, we can take the cube root of 8. That's 2. So on the outside, we have 2 times 2, and then we're left with a radicand of 2. And then our second term and our third term just stay the same. Now we want to multiply these two coefficients in front of the first term so that we have 4 cube root of 2. And then we have the cube root of 2 for the second term and the square root of 2. And now we can combine the first two terms since they have the same radicand, 2, and they have the same index, 3. So 4 cube root of 2 plus a cube root of 2 is 5 cube root of 2 minus the square root of 2. Not too bad. Remember, just always simplify those radicands as much as you can. And if they have like radicands and the same index, they're like radicals and you can add or subtract them. Now, what if we multiply? Multiplying radical expressions, you're just going to use FOIL or distribution. So for example 1 and 2 here, we're given two expressions that are binomials. So we're going to use FOIL. So in example 1, the first part is to multiply the first term from each. Square root of a times square root of ab times square root of ab. And then outer, we multiply the two outer terms. So that's plus 3 times the square root of ab. And then inner, we get minus 3 square root of ab. And then the L, the last two terms, minus 3 times 3. Now notice when we multiply the square root of AB times the square root of AB, it's the same as the square root of A squared B squared. And that actually simplifies to just AB. So whenever you're multiplying the square root of something by itself, you just end up with the radicand. And now notice that these second two terms, we have plus 3 square root of AB minus 3 square root of AB. Those cancel each other out. So our next term is just going to be negative 3 times 3, or minus 9. So that simplifies to AB minus 9. Now if you go back to this original expression real quick, notice that we had the square root of AB minus 3 times the square root of AB plus 3. If you remember back to when we learned factoring, this is what the difference of squares factors out to. So we know from factoring the difference of squares that those two middle terms will always cancel each other out, which is what happened here with the plus 3 square root of AB and the minus 3 square root of AB. It's okay if you have to just FOIL. Sometimes I just FOIL to make sure. Let's look at example 2. So again, FOIL. So multiply the first terms together. So square root of x times the square root of x. Then the outer two terms, that's plus 8 times the square root of x. The inner two terms, minus 7 square root of x. And then the last two terms, minus 7 times 8, which is minus 56. And now we just slowly start simplifying. Square root of x times the square root of x. Remember, that would be the square root of x squared, or just x. Then we have plus 8 square root of x minus 7 square root of x. These are like radicals, so we can combine them, and we just get plus square root of x, and then minus 56. So our final answer there is x plus square root of x minus 56. Now that you know how to multiply radical expressions, we're going to move on to page 2 and talk about how to rationalize a denominator. So you need to rationalize a denominator whenever you have a radical expression in the denominator. It's not good math to have a radical in the denominator, so we rationalize it. If you have one term what you do is you multiply the numerator and the denominator by that radical that's in the denominator. And if you have two terms, you multiply by what's called the conjugate of the denominator. And the conjugate, it's a fancy word, but it's really just taking the existing denominator of two terms and changing a plus sign to a minus sign or vice versa. Sounds a little confusing, but it's not. Let's work through a few examples together and you'll see. So example 1, we have the square root of b over 12. While using our square root properties, we know that we can separate this into a square root in the numerator, square root of b, over a square root in the denominator, the square root of 12. Next is to simplify. We can't simplify the square root of b, so that stays as the square root of b. But notice that the denominator, the square root of 12, is the same as the square root of 4 times 3. And we can take the square root of 4. That would give us 2 square root of 3 in the denominator. And the square root of b stays in the numerator. Now, because we have a square root in our denominator, that square root of 3, we need to rationalize our denominator. And because we just have one term, we're going to multiply our numerator and our denominator by that radical expression, the square root of 3. And because we're multiplying the numerator and the denominator by the same thing, this is the same as multiplying by 1. So we're technically not changing the meaning of this expression. So now we multiply just like we multiply any fraction. Multiply the numerators together. So that gives us the square root of b times the square root of 3. And then our denominator is 2 square root of 3 times square root of 3. Now we can simplify the numerator. A square root times another square root is the same as a square root of those products as the radicand, or the square root of 3b. And then our denominator, we have 2 times the square root of 3 times the square root of 3. And remember from the last page, when you multiply a square root of something by itself, you just get the radicand. So we just get 3. And then we continue to simplify because the denominator 2 times 3 is actually 6. So our final answer is the square root of 3b over 6. Let's look at example 2, which is another rationalizing the denominator where we just have one term in the denominator. So again, first step, simplify. Our numerator doesn't have a radical, and doesn't have anything that can simplify, so it stays as r times t. Now, what about our denominator? We leave the 2 alone, but the square root of r cubed. We can take the square root of r cubed because the square root of r cubed is the same as the square root of r times r times r. So this grouping of r's would come out and we'd have r square root of r. So our denominator becomes 2r times the square root of r. And now notice that our numerator and our denominator both have an r in common, so we can simplify those out because they would become 1. So this expression becomes t over 2 times the square root of r. And since we have that radical square root of r in the denominator, we need to rationalize that denominator. So we multiply the numerator and the denominator by the square root of r. So that would give us a numerator of t times the square root of r and a denominator of 2 times the square root of r times the square root of r. And we continue to simplify. The numerator stays t square root of r. And then the denominator, we have 2. And remember, square root of r times square root of r would just be r. Not too bad. Let's scroll down and look at a couple more examples, but here we have two terms. So our denominator in this first example is the square root of 5 plus 2. And because that denominator has two terms, we need to multiply by its conjugate. And the conjugate is just rewriting that same denominator, but changing the sign. Since it was plus, we're going to make it subtraction. And we multiply the numerator by the same. Again, since we're multiplying the numerator and the denominator by the same value, we're technically multiplying by 1. And notice that the denominators that we're multiplying together, that's a difference of squares. So it's going to multiply and simplify down to just two terms. We'll walk through all the steps. So now we need to multiply. The numerator gives us square root of 2 times the square root of 5 minus 2. And the denominator is square root of 5 plus 2 times square root of 5 minus 2. In the numerator, we just have to distribute the square root of 2. So we have the square root of 2 times the square root of 5 minus the square root of 2 times 2. But the denominator we need to FOIL. So the first terms, we get square root of 5 times square root of 5. The outer terms, we get minus 2 times the square root of 5. The inner terms, plus 2 square root of 5. And then last, we get plus 2 times negative 2, or minus 4. And now let's simplify. So the numerator, square root of 2 times square root of 5, remember we can combine them under one square root, so that's the square root of 10, minus the second term, we're going to rewrite as 2 square root of 2, just change the order. And then let's look at this denominator. Square root of 5 times square root of 5 is just 5. And then the second and the third terms, they cancel each other out. So they're gone. So we're just left with 5 minus 4. And we can simplify further. Square root of 10 minus 2 square root of 2, our numerator stays the same, over our denominator, 5 minus 4, or 1. And technically we can simplify this even further. We don't need the fraction since it's over 1, so it's the square root of 10 minus 2 square root of 2. See, the conjugate's not too hard. You just have to remember that it's the opposite sign. So you change the sign in between the two terms. And the reason you do that is so that these two middle terms that have the radicals end up canceling each other out, and you no longer have a radical in the denominator. Let's look at this next example. So we know we need to rationalize the denominator, and we know our denominator is two terms, so that tells us to multiply by a conjugate. And our conjugate, we rewrite those terms, and we just change the sign in between them. Since it was subtraction, our conjugate is going to be addition. And we multiply the numerator by the same thing, just so we're not changing the meaning of the expression. And now we do the multiplication. So we know in the numerator that we need to distribute the square root of x to those two terms. So we get square root of x times square root of x plus 3 times the square root of x. And then our denominator, we know what's going to happen with those middle terms. So we really just have to multiply the first two terms, square root of x times square root of x. We know that the outer, is going to be plus 3 square root of x, and the inner is going to be minus 3 square root of x, so they cancel. So we just need to multiply the last, which is minus 9. And then we simplify. Square root of x times square root of x in the numerator gives us an x. Plus, we can't simplify 3 square root of x. And then our denominator, again, square root of x times square root of x is just an x minus 9. So there we go, we simplified it. So if you can remember, when you FOIL and you're multiplying the conjugates, you only need to do the F and the L part of FOIL, because the O and the I, the outer and the inner, cancel each other out. Again, if you can't remember that, just do all of the FOIL. They'll cancel each other out, and you still get to the same answer. How about a geometry example? So here we have a right triangle, and we need to find the exact perimeter of the right triangle, and then we're going to approximate the answer. So exact means keeping it in radical format. So no rounding, no approximating. And perimeter, remember perimeter is going along the outside or building a fence. So all we need to do are add these three measurements together. So we're adding the square root of 27 to the square root of 75 to the square root of 48. Well, all three of these have different radicands. So right now we can't combine them. But we can simplify each of these. 27 is 9 times 3. And 75 is 25 times 3. And 48 is 16 times 3. So if we take the square root of 9 times 3, we can take the square root of 9, which is 3. And we're left with a square root of 3. And in the second term, we take the square root of 25, which is 5, and we're left with the square root of 3. And then our last term, the square root of 16 is 4, and we're left with the square root of 3. Now all three terms have different coefficients in front, but they all have the same radicand of 3. So we can add the coefficients to get our answer. So 3 square root of 3 plus 5 square root of 3, well that's 8 square root of 3, plus 4 more square root of 3, that would give us 12 square root of 3, and our unit of measurement is centimeters. So that would be our exact perimeter. Now to find the approximate, you enter this 12 square root of 3 into the calculator, and you get that that is approximately equal to 20.8 centimeters. So remember, factor those radicands and simplify them as much as you can. And then if they have the same index and the same radicand, you have like radicals and you can combine them. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.